In this video, we're going to start talking about bivariate data and talking about plotting and some relationships between variables. First of all, just kind of an opening problem. In the second game of the 1989 World Series between Oakland and San Francisco, 10 players went hitless. 8 players had 1 hit apiece, and 1 player had 3 hits. What were the mean and median? So I guess the sum, 8 players had 1 hit, so that's 8, and Ricky Henderson had 3 hits, so we have a total of 11 hits divided by, we had 10 that went hitless, 8 that had 1, and 1 that had 3, so a total of 19. So there's your mean, there's your X bar. And the median, imagine lining these up that you've got 10 zeros followed by 8 ones and 1 3. The median is going to be 0. All right, so we're going to start talking bivariate data. Everything up until now has been what's called univariate. Univariate means you've collected one piece of data, a height, a weight, an arm span, number of aunts, number of cousins, something like that, and you've found the mean, the median, the mode, standard deviation, range, z-statistic, but everything has been one piece of data from a person or an animal or whatever. Now we're going to start collecting 2 pieces of data. And we're going to call this relationship, or we're going to start talking about these relationships between variables. We often refer to them in a response and explanatory way. A response variable describes what happened, and the explanatory variable attempts to describe why it happened. Okay, so a piece of data that I've collected that I'm going to talk about in the next video is the number of miles a student lives away from school and how long the student takes to drive to school. The mileage would or the number of miles would explain why it took so long to get to school. Okay, so the explanatory is why, the response is the outcome. So I have some examples here, and I'm just going to write an R or an E next to which one's the explanatory and response. The hours of studying and GPA. I would think, for by and large, for most students, the hours of studying would explain the GPA. So the hours of studying would be explanatory, and the GPA would be the response. Response time and hours of sleep. So response time, there are lots of tests to do that, but it's essentially, how fast are you in response to something, some kind of stimuli, pressing the brake in the car or grabbing at something. And I would think that the more tired you are, the harder it would be to do that. So hours of sleep will explain the response time. Age and vocabulary. Well, I would think that the older you are, the more words you know. So age would be the explanatory, and vocabulary would be the response. I'm going to move this out a little bit because I need to write next to age. Okay. Then response time and blood alcohol level. Well, I think, again, this is why we have laws about this, that the amount of alcohol in your blood explains why you may have a slower response time. Amount of stress and amount of debt. And again, I think this will explain this, that the more debt you have, probably the more stress you have. Okay, so this is, like I said, this is the way oftentimes we describe bivariate data, is in an explanatory response way. It feels like this is verging on cause and effect, and in some cases that might be true, but I'm going to show you kind of a ridiculous example that maybe throws a wrench into that a little bit. This is one of my fake kind of studies and to show you, so I title it A Ridiculous Scatter Plot. I just want to talk first of all about really the way we label graphs like this. And we've got to be able to label. The explanatory variable goes on the x-axis. I'm going to put an E here. And the response variable goes on the y-axis. axis, and this is the way we've always graphed. You know, we put in an x and into an equation, it spits out a y. The x is what explains what the y is. So we label, we've got the units, we've got our explanatory variable labeled down here, our response variable labeled over here. So here's what this scatter plot represents. It is that shoe size explains reading score. And you can see an upward trend here that the bigger shoes you've got, the better reader you must be. I hope you look at this and see a huge missing variable, and that is age. This data was collected for middle schoolers, so 4th through 8th grade, okay, in that middle school model. So 4th through 8th grade, the missing variable, of course, is age. And obviously, the older you get, hopefully, the better reader you are, but you also will have bigger feet. So these are probably your older students, and these are probably your younger students. So like I said, you know, I think get in this habit of thinking like cause and effect, explanatory response. This isn't a cause and effect situation at all. Having bigger feet does not make you a better reader, okay? So something to think about, that just because a graph looks good, and this graph does look pretty good. I think we could find the equation for a line that goes through here and it would fit the data pretty well. Just because an equation looks good doesn't mean the data is good, and it doesn't really mean we're being told something about these variables' effect on one another. So keep that in mind. Okay, we're going to move on to the next video, and in that we're going to talk about describing bivariate data in graphical form.